My name is Brita Zimkis, and I'm the Director of Collections Operations at Harvard's Museum of Comparative Zoology. I'm here to introduce MCZbase, an open source platform for biodiversity data management. I will also highlight some of the newer features that were implemented in the recent redesign of the application. MCZbase is the collection management system at the Museum of Comparative Zoology. It's home to over 2 million cataloged items, representing almost 8 million specimens collected from across the globe. MCZbase is an independent instance of the Arctos platform that offers a suite of tools for linking, displaying, and managing our natural science collections data. Specimen records are data-rich and include dynamic linkages to both other pages and outside sources. In addition, there are numerous useful tools available to both public users and data managers, facilitating more complex interactions with the specimen data. After migration to a centralized database and decades of digitization work, all of the data for items cataloged in our 10 departments is now centrally accessible through this single platform. MCZbase now supports mobile devices such as smartphones and tablets, providing instantaneous and up-to-date access for researchers in the field, staff in the collections, and students in their classes. Data in MCZbase is now more accessible and discoverable. The Browse menu offers several entry points into the data. From this menu, users can explore some of MCZ's featured collections, which highlight expeditions, grants, and important historical collections. This page allows for the exploration of MCZ's primary types, as well as specimen records based on higher geography, island groups, and taxonomy. If we click on the Mobilizing Millions of Marine Mollusks of the Eastern Seaboard, or ESB, featured collection, we are brought to a page about this grant-funded project. Authorized MCZbase users can create featured pages such as this by writing a brief description and adding the relevant specimen records. MCZbase automatically generates a web page that can be shared with the public, highlighting all the linked data associated with the specimens in the grouping. This tool is also useful internally, allowing curators and staff to track grant progress and obtain data needed for reports to funding agencies. The web application supports basic, keyword, and complex searches to meet the needs of all of our stakeholders. The basic search is focused on the most queried fields. The keyword search is a free text search on multiple text fields, allowing users to query specific terms and retrieve a broader set of results. Finally, the search builder is the most complex tool, allowing users to query one or more of 300 fields or attributes in the database. For all three search types, the form and results occur together on the same page, making it easy to adjust search terms as the data is explored. At the top of each specimen record, the collecting data are summarized, while more detailed information is available in the sections below. Information about the current identification and type status is displayed. Clicking on the taxonomic name brings us to the full taxon record, where we see the higher classification and links to the external name authority, as well as more detailed information about the taxonomic name and MCZ specimens with that identification. MCZbase enables the exploration of the people and history associated with our specimens. Under collectors, we see names with yellow icons next to them. Clicking a yellow icon will bring us to an external registry of researchers, such as VIAF or ORCID, connecting people with their scientific contributions using a persistent digital identifier. If we click on one of the names, we are brought to an agent record, which assembles the person's work and displays biogeographical information from MCZbase data. Specimens collected, prepared, or identified by the agent are linked from this page, and a heat map of the collecting events allows users to quickly see where this person conducted their work. This page also shows their roles in MCZ transactions, such as accessions or loans, and lists their authored publications, including but not limited to those citing MCZ specimens. MCZbase stores collection data in approximately 50 core relational tables and 350 ancillary tables to support the needs of curation, research, and teaching. Data management functions cover all aspects of physical specimen and data curation, offering numerous tools that increase efficiency and improve data quality. In-house development allows us to make improvements and enhancements based on evolving best practices. For example, we can now track permit documentation in relation to accessioned material and paperwork associated with shipments. MCZbase is a modern application that adjusts to the needs of its users in a scalable way. Here we can see how the presentation of the data for the same specimen record has evolved over 25 years. By adhering to software engineering best practices, it enables development to proceed responsively to users' needs. MCZbase is located on secure, high-performance servers hosted by Harvard Research Computing, in accordance with the university's security policy. The codebase for MCZbase is openly available in a public repository with snapshots archived and citable with DOIs. The ability to edit in real time means data is live, and changes are immediately visible to users, facilitating rapid integration and community-wide rollout of new features. As part of a long tradition of sharing data with the community, data from MCZbase are made available to various data aggregators, such as GBIF, iDigBio, and VertNet. By enriching our data with both internal and external links, helping to create and follow global standards, and participating in the discussion and implementation of the Global Digital Extended Specimen Network, we work to keep that tradition alive. We thank you for your attention and invite you to explore the data associated with our specimens at mczbase.mcz.harvard.edu. I would also like to extend my thanks to members of the collections operations team that helped put together this presentation, including Brennan Haley, Paul Morris, Michelle Kennedy, and John Woodward.